Welcome to ArcGIS Runtime, building 3D applications. My name is Rex Hansen. I'm a product manager for ArcGIS Runtime. I'm joined by Adrian Maria, dev lead in our 3D effort within ArcGIS Runtime. We're going to take you through building 3D applications with ArcGIS Runtime. Keep in mind, ArcGIS Runtime is for building native applications, just as this is kind of the motto slide here for what ArcGIS Runtime is meant to do with respect to being able to empower, build out, clean, simple mapping visualizations, as well as work with complex geospatial or sophisticated capabilities too. It's designed to be able to build out native applications that can take advantage of local resources. So we're optimizing for speed and performance. We're building into or working with existing developer frameworks. And so if you're a native app developer and you're working with Visual Studio or Qt Creator or Android Studio, obviously Runtime is designed to integrate with that. We work with a set of online capabilities, services through ArcGIS Online and Enterprise. Obviously, we provide support for cross-platform or cross-device capabilities. We're supporting things like Windows, iOS, Android, Linux, and Mac. We provide developer frameworks that allow you to target and share code to target multiple platforms. So it's part of just sort of built into Runtime. The last thing here is we work offline. So that's one critical capability and feature of working with ArcGIS Runtime is working offline. So we'll talk a little bit about that here in the context of 3D. So just a brief rundown on a couple of things we're going to talk about. Sections we'll talk about in the context of ArcGIS Runtime or 3D and ArcGIS Runtime. In this case, we're going to be talking about scenes, kind of the entry point into working with or the container, the visual container that you're using to hold 3D content or content that's rendered in 3D. And then different capabilities or at least layers within 3D, such as elevation and other layers such as scene layers and feature layers, symbology that's unique to 3D, as well as the ability to navigate and manipulate your view space within a 3D experience, and then also analysis at the end here. So we'll obviously, towards the end, we'll finish with a couple of demos, and Adrian will drive us through a couple of those demos to show off some of the capabilities we have. One thing to keep in mind here is it's ArcGIS Runtime in the sense, ArcGIS Runtime is cross-platform, and so even though you might be choosing to develop in Android or develop in .NET, or develop in iOS, we're still built on the same common core, right? So all the functionality that we talk about here is available pervasively across all Runtime SDKs on every platform. So keep that in mind. Not unique to a specific Runtime SDK. So the first thing I want to highlight here is scenes, right? The entry point into or the view of your 3D content. There's really two things here within the API. There's a scene view, which is a control in every one of our APIs. This renders data in 3D. It also contains both a scene, which has operational data and base maps. It also allows you to add transient data such as graphics overlays, and enables the interaction that you have within that control with your 3D content. So the scene itself defines how your operational data is organized, how operational data is organized, features, scenes, as well as base maps and elevation sources. And so all that is contained within a scene. Think of the scene as really a document. Right, and that document is being used or is being displayed by a control, the scene view. What we see here is just actually a quick screenshot. We've actually got a browser up here with a scene, a web scene in it. We're consuming that web scene in Runtime. In this case, we're using markup looks like XAML for .NET, and we're rendering that in a .NET app on the back. A couple of things to think about here. We've got a couple of releases of ArcGIS Runtime out the door. We started targeting 3D on mobile last year. Our first phase of supporting WebGIS, 3D WebGIS was update 3 of last year. We started supporting the ability to consume a web scene and render what the content of that web scene was last year. We actually have a release that's pending. We have a road ahead session right after this, Primrose B, in case you're interested, where we'll talk about some new 3D capabilities. Some of that functionality that we've added since the last Dev Summit, I'm going to highlight here in yellow. We'll talk a little bit about. So update 3 went out middle of last year. We supported the ability to read and render a web scene. And so this is a document, a common document that can be used to define 3D content that can be read in a number of our clients, Runtime, JavaScript, and Pro. In addition to that, in Update 5, we're adding this next release of Runtime. We're going to support the ability to archive or create a package of your 3D content with your scene document and go offline. Right? So much like a mobile map package takes a map and its data offline, mobile scene package will be available or be able to be created through a provisioning system that's available through our desktop product, ArcGIS Pro. So in the backline here, you'll see ArcGIS Pro. We've created basically a scene with a set of layers, elevation, an elevation layer derived from USGS DEM data, Cache is a lurk encoded TPK. We've got display information coming from an ArcGIS Online base map, right? So that's another TPK. And then in this case, we've got a point cloud layer, which is another new layer type that we're adding in the next release of Runtime. And we can see the parallels here in the common rendering here within both Pro and Runtime. So the key here is mobile scene package is a nice, clean archive for being able to take your data offline from Pro and provision that onto a device. Keep in mind, we've got full support for offline. Right? I know this question's come up a few times. You can go offline today. This just makes it a little easier to go offline. Right? So the ability to work with both online services and offline data, whether it happens to be a TPK, a mobile geodatabase, a raster file, a shape file, geo package, all that works in 3D. So you can take that offline today. The mobile scene package just gives you the ability within desktop to be able to provision that information in a way that you can take it offline in a single file, a single archive, along with the scene definition. So full offline. Another component of this is elevation sources. You're working in 3D. Usually you're draping your content, or at least you're showing content in the context of a 3D experience. And so generally that involves the surface of the Earth or a surface. And so being able to represent that through elevation is key. So our elevation sources is a collection. This will define height values across a surface within the scene itself. You can have one or many, and you can interrogate values within that elevation source to be able to get back an elevation value. There's a set of sources here. One is online, so an ArcGIS image service. Supports, can be used as an elevation source. We have a global elevation service that ArcGIS Online hosts that you can use, no cost. You can take the image service offline, actually, so you can generate a TPK from the image service. It'll contain things like, it'll contain lurk encoded imagery, low compression imagery. It's basically, it's an open format that we've published, but what it does is it enables for a quick and efficient use of tiles, image tiles, offline for elevation sources. So I can create a tile package from an image service. I can also create a lurk encoded rasters within a tile package in Pro. Do the same thing. I can also use a local raster. So if I've got a DEM and I want to be able to access that locally and work with that directly, I can do that in 3D as well. So a couple different options there for providing support for elevation sources on which to drape, or at least to show 3D content and provide a more realistic experience. This slide looks a little empty. We're going to fill it up here shortly. Nice. Scene layers, right? So scene layers are, really think of them as, scene layers are optimized for display in 3D. It's based on an I3S spec. This is a public specification, so indexed 3D scene. That I3S spec defines a variety of different types of being able to create 3D data that, again, is optimized for display in 3D. The first one is 3D objects. Think cached multi-patch data, right? Volumetric objects. In this case, it might be multi-patch with textured imagery to provide a photorealistic experience of buildings. Another one is integrated mesh. Think of a tin. That tin actually has colors for each individual triangle. Within that mesh, it's a continuous surface, and so this could actually eventually be used as a surface, but it might be something that you gather through, let's say, drone imagery, and then able to display that effectively within both within Runtime. A new layer type that we're supporting with i3s is point cloud. So you might have started with LiDAR data, a lot of information. You could be talking hundreds of millions of points. And as LiDAR data, you have a set of analytics or different render capabilities you want to be able to take advantage of. We'll be able to support read of point clouds directly in Runtime in the next release. And another one is point. Now, this is actually just standard features. It's just, again, optimized for use and display in 3D. So right now, the i3s spec defines support for points. Eventually, it'll include support for lines and polygons. But this, with the pervasiveness of 3D across the Runtime, across the ArcGIS platform, including Runtime, we need to be able to support effective display of point data. So think of this as point features that have been cached for use or optimized for use in a 3D display context, right? So generally being used with a 3D symbology. Of course, some of these layers support identify and select, right? So the ability to get access to additional information. So for example, building information with a 3D object in a scene layer. Select, being able to select an individual building and get information about it. So interactivity is available. That's something that's been added within the last year. And there's a couple different ways to gain access to these. One is ArcGIS Scene Service. You can publish scene services in enterprise and online. Also a scene layer package. So working in Pro, creating maybe starting with the original source data, let's say multi-patch data with textured buildings and generating a scene layer package for use in runtime. There's a number of different ways to do this. It's really an analysis tool that's available within Pro. Easy to create, easy to use. If you create a mobile scene package with a layer in it that ends up becoming a scene layer, that SLPK, that scene layer package, will be an archive within the mobile scene package archive. Right? So we're still taking advantage of that even when creating a mobile scene package. Great, so let's take a look. There's some additional layer types here I just want to highlight. The key here is that when working with feature layers is that we have both dynamic rendering and static rendering. Dynamic rendering are features we see on the top here. This is static, so these features are draped by default. That's great. It's CPU based. You can actually you can render quite a bit of data, but you'd end up having this sort of a sticky experience actually with navigation of the scene. All different feature layer types, whether it's coming from feature services, mobile geodatabase, shapefiles, geopackage, et cetera, will enable the ability to work with either dynamic or static rendering. If you're working with dynamic, which is the preferred method, it's GPU-based rendering. You can billboard marker symbol, as you can see here, as we start to tilt the Earth. The symbols, instead of being draped on the surface, they will actually face the camera. They'll also honor scene placement, so they can be relative or absolute based upon the surface. And with this, if we had polygons, we could extrude these quite easily as well, so it provides some level of flexibility. So a couple things to keep in mind there with respect to feature layers. Another thing we're adding is KML. So KML was added in Update 4 last October. Read and render, we're going to add support for tours. Built-in support across the platform for tours in our next release. So better support for KML. Obviously, direct read of raster content is supported. We can drape that within 3D raster tiles. And so these are raster tiles that might be coming from a ArcGIS tiled map service, like think of a base map, or it might be something coming from a TPK or a tile package. Right? So something we can access both online and locally. And the last thing here, group layers. Anyone excited about group layer addition? Anyone like group layers? Anybody need group layers? Yeah, I see some hands. Nice. What's that? It's a love-hate. I know exactly. You don't want it, but you know you need it kind of thing, right? So group layers is being introduced in our next release. Group layers is actually being driven by the scene spec. So the scene spec exposes group layers as part of the spec. To have better support for 3D WebGIS, we need to support group layers in runtime. There is a document experience here with respect to a scene document. There's also a developer experience. So you can create a group layer, you can work with it within a scene, you can create a group layer and use it in a map too. Good stuff, but it's a developer experience right now. WebMap will probably have that later this year. So I want to highlight that here because it's been a popular need. 3D symbology. Of course, when working with 3D symbology, there's different mechanisms or capabilities you can leverage. Of course, the web scene supports extrusion. We support extrusion within the web scene spec supports extrusion. We also support extrusion from a developer perspective in runtime. There's a set of different 3D marker symbols that are designed to provide sort of a volumetric experience or a model experience here within runtime. Model marker symbols, there's a variety of different formats like OBJs and DAEs, Collada files that we can work with directly. There's a set of there's obviously a set of other symbol types that we can use with respect to other feature types. So, for example, tube symbol is pretty popular, something that you can define today within a scene. We support that now in Update 5, so that's great to see. More complete story. With our symbols in general, in Update 5, we're providing a proper developer API that enables you to access the symbol and multiple layers within the symbol, and so there's an API to access that. Web styles. Web styles are primarily a set or maybe a collection of styles that are right now advertised as entry points or items within ArcGIS Online and ArcGIS Enterprise. Those styles contain things like trees, transportation vehicles, a variety of different related models that you can reference and then use within runtime. There's an example in the upper right there. And then distance composite symbol, which is something that's runtime specific right now, which is being able to change, sort of think of it as like a scale dependent render in a way. As you zoom in and out, you can change the complexity of the symbol so that you make sure that you're rendering or you're leveraging rendering as needed. You're not over rendering, actually, right? Rendering too much complex data at a unnecessary distance from the camera. Great. Cameras, viewpoints, and controllers. This really just kind of highlights the fact that this is a developer API. You're going to be using the camera to be able to define, and the viewpoint of that camera to be able to determine the orientation of the viewpoint within the scene view. And so that scene, actually that geo view in this case, will give you the ability to work with a viewpoint and define a viewpoint and work within in the context of that viewpoint with a camera. There's a set of controllers that allow you to orient how you work with or how you work within a scene, and those controllers allow you to be able to define how to navigate. So that might be a global-based navigation, Earth-centric. It might be centered on a specific point or location actually within your 3D context, such as around a target element like a plane. So you have a variety of ways of controlling this. This just highlights a set of those calls that you might be working with or types that you might be working with in runtime that would be key to use. Exploratory analysis, we introduced some visual analysis capabilities within runtime that were really visual, interactive. They were not persistent. The visual tools themselves use what's actually in the scene. So content of the scene, they're powered by the GPU, so they're designed to be quick. The first one here is line of sight, and so we can choose different points to determine if one point is visible from another. Another one here is view shed. We can see a little animated GIF here where we have a plane, a location, an element actually, and as that element moves, we can see the frustum as well as what's visible and not visible. What's visible is in green, what's not visible is in red. And we can do a quick visual assessment with some of this visual analysis. We also added the ability to do measure, and so this is a recent addition within the last year. So you can do an interactive measure and get additional details visually, actually within a scene. All right, great. So a quick rundown. And with that, I'm going to hand it off to Adrian. He's going to take us through the 3D experience.
Thank you, Rex. So, So I'm just going to, help you get your feet in the first 3D programming using the runtime. Your first point of access for any development at Esri is really that website developer.arcgis.com, and that's really a really good entry point and also a good place to find any kind of help and resources that you will need for your development. All you need is basically choose which platform you're targeting. So I'm just going to start my demo with the .NET as an example. So you arrive to the ArcGIS Runtime SDK for .NET, which has all the guide to help you either just trying to install the SDK really the first step, or doing some way more complex scene with some analysis on top of your 3D environment. You obviously have the API ref if needed, but as a developer, what I really like is just find a sample that does pretty much what I want and grab the source code, do a copy paste into my project and use this. And definitely from that website is something that you can do. So every SDK on this website has pretty much the same structure, and share actually is actually the same list of samples. So you can go ahead and choose your platform and download the sample that will fit your platform and run it. And that's exactly what I have running here. There's no Visual Studio. I didn't install anything. All I did is grab the sample app and run it on my computer. And that's a really good way for you to see what you can do and then get inspired. And then you actually, when you dive in, you can actually see how you can do it by looking at the source code. So to start with, I'm just going to highlight some of the things that Rex just mentioned, and it's just be able to display a scene. So as you can see here, all I have is a globe, and what I first do is I just zoom into a specific area, and the internet connection is not that fast, but when you arrive, you do see that he has buildings on top of tiles, and I can actually interact with it with keyboard, mouse, and all that interaction. And if you want to look at what the source code is like, you just tap the source code tab, and I'm going to make it slightly bigger. But the idea is exactly what Rex added in his slide is you first add, you have a scene, and that's your entry point to 3D content to be represented in your application. And you add some elevation because you want to be able to see those mountains, and everything will be draped on top of that elevation. Then we actually add the building service. So those were the buildings that we could see in the scene, and we actually loading that layer. And after that, you're just basically setting your camera to be in the point where you want to look at those buildings from initially. And we're setting that camera asynchronously, so the camera is actually animating from wherever it started to that particular point. So with just a simple line of code, you already have a 3D application, and you're able to interact with it and represent the data. And so that's the building here has the scene layer and I3S specification that Rex just mentioned earlier, and that's a scene layer of type building. If you don't have a computer with you right now in your lab that I can see, but most of you guys have a phone somewhere. So what we could do is, if I find the right number, because it's not written in my input, here it is. If you have an iOS device, for example, you can do exactly what I showed you. I told you that all our APIs share the same sample app and everything. You can actually go to the App Store and start typing ArcGIS Runtime. It's easy for me because then I don't have to, ArcGIS Runtime, and then you have the ArcGIS Runtime SDK sample. So you can do it today on your device and just download the application. So all I'm going to show to you today is something that you can just right away do and test and get inspired by. One of the, so there's a scene tab there which regroup everything we just talked about that Rex just mentioned, but let's dive into scene symbols. So, you can consume in 3D, you can consume every symbology that is 2D specific, but you also have a set of symbols that are specific to 3D. So those are the default one, but then you also have some little bit more advanced symbology that can come from different 3D format like DAE and OBJ and everything that you can actually use in your 3D application. And once again, so here I'm on an iPhone, and you can see how the application is still really, really responsive, and as I'm following this plane. And this particular sample has a bunch of capabilities where you can pause, play, and get stats from where the plane is, what it's looking at, and things like that. But once again, exactly like in the .NET application I just showed you, you can actually go to the Info tab and get more information about the sample you're looking at, but also get the source code and see exactly how that sample got done. That source code is also available on GitHub, which make it easier for developer to copy paste. But at least just running that on your phone will give you a good idea of what you can do and how it's done behind the scene. There's no smoking mirrors here. It's actually the source code of the application that you're looking at. So we talked about 2D graphic too, and how they can be used in 3D. And that's an example of 2D graphics. Those are just features, draped on the ground when you look at them on the 2D aspect. But when you represent them in a 3D scene, you can actually do really interesting things with them. And one of them is extrusion. That's actually a really powerful way to get a message passed. Like it has a way better visual impact to see a graph height instead of its color or things like that we will do to represent in a 2D environment. And actually, before moving to the analysis tools that Rex mentioned also, I'm going to try to get, we had some trouble with Android that doesn't allow the phones to be directly connected to the projector, and I have some trouble with the projection system on my computer right now. I'm going to give it one last try, and hopefully, I think that's number 5. It seems to be working now. So, yeah, I want full screen. Here it is, magic. So I just show you on iOS, and we just say that all our APIs are sharing all the common APIs, all the same API, all the same samples and everything. So I decided to prove it to you, and now I'm opening the Android Google Play Store, and same thing here. If I tap ArcGIS, I should type it correctly without space. The first one actually has 5 stars, so you know it's good, right? It has 7 reviews. There's probably 7 people working on it at Esri. And then you can open it, and it's exactly the same type of application I just showed you on iOS, I just showed you on .NET. Same thing, you can download it today on your phone and actually start using it. So Rex mentioned some analysis tools. And you can see some, for example, the measure tools running here. And so you could see, again, elevation and imagery. Right now, that's all you see. And we're waiting for the scene layer to come. Might take a little bit. I wanted to mention that as soon as the scene layer comes, here it is, those tools are not only shared between each API inside the runtime. Those analysis tools are shared across the platform, which means if you use them in JavaScript, if you use them in Pro, they will look and feel exactly the same. So it's a really good way to show the 3D capabilities shared all across Esri product. And I can modify where I'm measuring from and get the data out of it. Once again, I can dive into the source code and actually see how that measuring tools is done. It's a little bit more of code. I'm not going to dive into it, but especially that it deals with type input and stuff like that, which are really platform specific. But you get the idea that we have so many samples that you can grab a snippet of code from, and to help you kickstart your project. One of my favorite one is actually the view shed. So let me just run that sample. So here you can see a combination of things. So first thing is that we have a 3D symbol here, which is a tank, and we're actually running a view shed analysis from the tank. And as usual, there's elevation and a tile layer on top of it, so you can see those imagery of the streets. And there's also a scene layer, and those are those untextured buildings. I2S services coming, we call them of type 3D buildings, can be textured or untextured. And to show you that this analysis actually is running on the phone, I'm just gonna make that tank move, and you can see that as the tank is moving, the analysis is done on the fly. And same here, you have access to the sample code if you need to grab anything from it and build something inspired by that sample. It's really that simple. There's also some new types. Viewshed tools, is really, you have a full control of, the heading of what you're looking at, the pitch of what you're looking at, of how you're looking at it, so higher up or lower down, and it really runs really smoothly, even on low-end mobile devices. So one of the new type that Rex just mentioned is that, so I actually have a different version of the app that is than the one that is in the store, because I actually have a point cloud layer. So that's coming at update 5, and that's simple. Oops. Okay, that's a policy. It's showing you for the first time consuming point cloud data on a mobile platform. And it's just point cloud is another I3S spec type of scene layer, and I'm consuming it inside my Android application on my phone. So that's all the samples I wanted to show you today. But once again, you can download the app, look through all the samples. We have a lot of 2D and 3D samples there, and the source code is available. And as a main resource, developer.arcgis.com is definitely a really good place to start and get all the resources you need to build your 3D application. Back to you, Rex.
All right. Thanks, Adrian. There's a little screen grab of Adrian up at the UC Plenary, I think last year. Is that right? Yeah. In front of your 15,000 of your best friends. Good stuff. There we go. So he's run some great demos. Good stuff. So we got to see a little bit of what's out there today. Obviously, everything that Adrian showed is available, except for the last demo, which will be available here shortly when Update 5 rolls out at the end of this month. This isn't a road ahead here, just a brief road ahead of what's coming in Update 5 at the end of March. Update 5, 100.5, mobile scene packages, we talked about that. We just showed point cloud scene layers, just showed it. Point scene layers, so being able to cache points for optimization and display in 3D. Subsurface, display and navigation. You want to see a demo of this, come to road ahead. We'll show that. Group layers and KML tours, a couple of key things here that factor into 3D capabilities that we'll be rolling out here at the end of the month. As far as what's coming in the next release, we've still got there's a few things that we're still evaluating from the context of 3D. We're looking at, we don't support vector tile layers at the moment, so we're looking at supporting that. Some additional capabilities on top of our scene layers, such as the ability to define a renderer or filter. Some of those things we're looking at rolling out as well. So the ability to read and render is there. We just need to be able to enhance the API a little further. But one thing we are targeting is AR on mobile devices. And this is iOS and Android in Update 6, so a little bit later this year. So what I'd like to do here is talk a little, well, actually we could show a demo first. What do you think? Sure. All right, let's show a demo of AR here. So Adrian's got a demo of AR working. It's a small scale or tabletop experience. Maybe it could be even a floor top experience. We'll see what happens. You good? Okay, cool. So what Adrian has here is he's working on his iOS device. He's got an application that he's built. He's got an integrated mesh SLPK locally on the device, and using ARKit, we saw a set of points, surfaces that were being detected by ARKit. He tapped on one of those points and he placed this integrated mesh scene layer package, integrated mesh layer. It's about a 4 gig layer, about 4 gig in size. And so now notice that he's not using his screen to touch and tap and maneuver and manipulate. He's using a natural movement, right? So he can move in and out as he moves the phone. It honors the location relative to where it started. So he can actually do things a little more naturally. He can move his phone around, move his body around, actually, the landscape as if it was actually a physical model that existed in real space. So we're using the camera feed synchronized with virtual content that's being displayed using Runtime's rendering pipeline. Now this is just a navigation of that content, but we can also take advantage of some of Runtime's capabilities. And we saw some of the visual analysis tools that are possible within Runtime. And so we can tap a point and get a view shed here from that point to see what's in green, what's viewed, what's visible from that location. It's programmed here. It's developer API. We've programmed it to rotate so that as you rotate around, I believe this is, like 60 degrees? To be able to see what's visible from the point that was tapped. And then we also have the ability to use things like viewshed. Like line of sight. And so we can tap a point, a source, and then see whether or not that source is visible from a specific location. And as that destination point is visible, it'll be green. If it's not visible, it'll be red. So we need to find a place where we can see it. Is it down in there we go. Ooh, yeah, looking good. It's a tight niche actually in Yosemite there. So great. So what we're showing here is just being able to leverage some of the 3D capabilities that are already built into Runtime today. We're just taking advantage of those 3D capabilities, and we're really supplementing that on top of ARKit and ARCore capabilities in iOS and Android to synchronize a camera feed with virtual content to provide a mobile AR experience, which is great to see. So that's one thing that we're targeting. That's a nice demo. What we'd like to do here is just talk a little bit about what that means. There we go. Okay, so this is more of a kind of an extended reality in ArcGIS Runtime in general. So right now, enhancing ArcGIS Runtime SDKs and the 3D capabilities that are in them with an AR capability is part of a beta product, a beta offering that we have. It's a private beta. Again, augmented reality, mobile platforms only. That's the rendering pipeline that we can support. We're looking at making this available for production use within the Update 6 timeframe. So we're going to build out a platform that supports this AR capability, and then we're going to release, our plan is to release this capability as part of our toolkit. It's going to be, think of it as another control within the toolkit that allows you to be able to synchronize camera feed with virtual content and be able to take advantage of different ways to get better sort of location accuracy and positional accuracy that you can use and build upon within your custom-built application. Keep in mind, it's not for virtual reality, whether mobile or premium, or for mixed reality, that holographic experience you might find with a HoloLens or a Magic Leap. It's not built for that. It's really built just for mobile AR experiences. So if you're a runtime developer, you're using 3D, and you want to be able to take advantage of the sophistication of runtime and really kind of light up that AR experience on a mobile device, iOS and Android, this is something that's designed for you. And there's actually, this is a brief demo here of one of our customers that built out a solution using the AR capabilities, and he was targeting the iOS SDK. In this case, it's water infrastructure, and so we can see some of the pipelines. They've been, basically they're snapped or they're floating on the surface. You don't get parallax, actually, so that's a difficulty with a flat single screen. And so in this case, they want to know where that line intersects with the surface. You can see there's a model marker symbol here to showcase manholes. There's also labels and billboarded text here to kind of showcase information about other assets that are associated with this utility. So an interesting example here of using ArcGIS Runtime and the beta program itself. And it's part of the beta program. The next part here is we're really looking at, this is just sort of something for the future. We're looking at game engine integration. And so we have some research in progress here that we'd like to be able to target mobile and premium extended reality experiences. This is merely across the platform, really coming from a game engine perspective. It's a lightweight API, access to a variety of different data sources that are live and local. Think about raster tiles for display and elevation, features like points, lines, and polygons, really geometry that you're enabling access to within a game engine, and then you're using the game engine's capabilities, the animation, the physics, and such, to be able to take full advantage of that game engine experience. And then i3s, I mentioned this before, as a format, being able to get 3D data into your game engine to build a real world experience. And we've got a couple of examples here I've shown. This is an example from Mimum, one of our partners that's built out a solution, a custom solution within a game engine. They're using Unity, and they're rendering line and point features here with a variety of symbols. This is coming from a feature service. And then another partner here, Arcon, on the right-hand side, they're building out a virtual reality experience here to train individuals that are driving a locomotive, actually, and being able to simulate that experience. And so they're using, they've built out an i3s reader, so they're bringing that into their experience, their virtual reality experience, and they're powering it through, in this case, an HTC Vive. Or it looks like an Oculus. Yep. Great. And so with that, we've ended a little bit early. So we could transition to questions. Actually, I do have a couple questions for you guys. Anyone building 3D experiences today with Runtime? We got 1, 2, okay. We got 3. I see over here a little bit, okay. Are you guys using which Runtime SDK for .NET? Okay, are you targeting mobile, desktop? Desktop, okay. Any other Runtime SDKs? Are you using Qt or Java? Anything like that? Okay, really .NET? Okay, good to hear. Anyone interested in the AR capabilities here with Runtime? Okay, good stuff, good to hear. Are you guys members of the beta community already? No? Some of them are? Okay, good stuff. I didn't have the email up there, I just realized. Interesting. There is an email alias that you can send it to. I'm going to save this thing. It's ArcGIS Runtime AR VR Beta at esri.com. Good luck remembering that one. If you'd like to become a member of the beta program, feel free to come up and let me know afterwards. I can give you some details there on how to email and request access. With that, any other questions on 3D capabilities and Runtime? Questions about the future? What you guys need? What you guys want? Yes?
So if you're building a Runtime app that's 2D based,
Mm-hmm.
and you want to have 3D capabilities,
Mm-hmm.
is there anything special that we need to be aware of, switching between the two?
Yeah. So if you're building something that's 2D based, you want to switch to 3D. Of course, you're doing it in a third dimension, so you have to consider those. There's additional capabilities you have in 3D. So additional things you need to think about, right? So in this case, you're not talking about an extent, you're talking about a viewpoint, right? And that viewpoint is not necessarily a rectangle, right? Usually isn't. So you need to consider those mechanisms for basically being able to navigate and calculate where you go actually in the 3D context. You're probably looking at things like elevation that you don't necessarily, and rendering that elevation appropriately. Performance is key here too, right? So you're oftentimes working with a lot more data in 3D if you're taking advantage of that. A couple things to think about. There's a couple of different data formats that we don't support yet in 3D. We're looking for use cases to do that. Obviously, I've mentioned vector tile layers is one of them. Things like S57 is another one. We won't necessarily support annotation yet. We also don't have labeling in 3D. Is that something that you guys would need going forward? We'd like to be able to close some of those gaps, but a couple of things that do exist today that we're looking to be able to close at some point. Granted, as a complement to that, we do have some additional layer types that are specific to 3D, right? So scene layers don't have a complement actually in 2D, right? They might have a feature service or a feature layer associated with them, but again, you're working in 2D, so expectations are limited, right? Hopefully that helps, yeah. So a couple things to think about. Yep, Martin.
The beta program you mentioned is for submarine also?
I'm sorry? The beta program? Yes, actually. So we do support .NET, actually. So right now, we're thinking that in the beta program, we'll target iOS and Android devices. And so that means any runtime SDK that supports iOS and Android. So .NET, iOS, Android, and Qt. We're targeting platforms that support ARKit and ARCore. Of course, we're relying on the platform itself to expose ARKit and ARCore in a responsible way so we can take advantage of it. We haven't yet, as far as I'm aware, in .NET, ARCore is not exposed in a way we can take advantage of it through Xamarin in a responsible fashion. So right now, if you're in the beta program, we have a beta 3 that's available for iOS and Android. Beta 3 is built on top of Runtime 100.4, right, which is the current release. With both iOS and Android SDKs, iOS, we take advantage of ARKit. Android, we take advantage of ARCore. With .NET, it's beta 2. So beta 2 is built on, 103? Okay. 100.3, we support ARKit as part of that. We just don't support ARCore in that context, which makes it difficult, actually, to build out a really good AR experience. And so we'll need that to be a requirement. Part of the reason why we're looking at introducing a toolkit component that powers this capability is we don't want to add that dependency to all of the runtime SDKs, actually. We want to be able to allow for developers to opt in, actually, to what they need. So, and we need the flexibility there within that ecosystem as well, just in case. Yeah. Any other questions on 3D? Yeah.
So Max, you earlier mentioned that HoloLens might not be supported anymore. Is there reason or what?
Yeah, so what we're looking at within the context of Runtime is we manage our own rendering pipeline within Runtime. So we have complete control over that. So when we initially released a beta, we thought, well, maybe there'd be a way to be able to build out a solution like that. But to be able to build a really effective, immersive solution for HoloLens or Magic Leap or those holographic experiences, we need to be able to really integrate within a rendering engine that's powerful enough to be able to provide an immersive experience like that, but at the same time provides the ability to respect distance and really occlusion, right, in that context. And so to be able to do that, we need to drive that development effort through a game engine. Trying to rebuild that doesn't give you a true experience. We thought about, well, maybe you could make it the size of the display screen, but it's still not an effective. It's a clunky solution. And so in the effort or the year and a half that we've had the beta program open, what we've got a lot of feedback to indicate that we need a game engine integration story to actually power these more sort of premium experiences. And we found that really the rendering pipeline that we've built Runtime for is sophisticated for GIS solutions, and it's optimized for that. For folks that know the platform, for folks that want to use or want to build native applications, it's designed for those folks. It's designed for people to build sophisticated GIS solutions as well as simple solutions too. But the rendering pipeline that we have there is not empowered actually to provide a responsive enough experience to be able to build a VR solution. And so obviously you want to have as lightweight a solution as possible there, and you want a rendering pipeline that's powered for that. Granted, behind the scenes, we're in the process in Runtime of optimizing our rendering pipeline, but it's not there today. At this point, it would be a multi-year effort to be able to do that. Instead of sort of reinventing a rendering pipeline that right now, a lot of these devices that are powering premium VR experiences, the development's driven through a game engine. What we'd like to do is be able to optimize that experience by saying, well, what are the needs in the market today? And usually the needs in the market today are, I've got a set of data, I want to be able to display it in an immersive VR experience or just a mobile VR experience. And the pervasive driver today, at least development-wise, is through a game engine. You're using Unity or Unreal. And you want access to data. It's not that you need, all sorts of visual analysis to be powered through, the ArcGIS platform. You just need access to your authoritative GIS data. And so being able to power that is pretty effective, is critical. And so what we want to be able to do is provide a lightweight experience. So we actually, it supports VR. So our beta currently supports VR, but it's designed for mobile, but it's going to be a little choppy, actually, with respect to the amount of the frame rate that you need to be able to provide an experience that doesn't get your constituents sick. Right? So we're not going to encourage that. So we're really going to be encouraging AR at this point, mobile AR, right? Yep.
One more follow-up. Display last week or so, Microsoft announced their
HoloLens 2?
yes, that's exciting. The other part of their announcement was the other spatial access.
Yep.
If you guys think that will be a bridge to that part of it.
Right. I think that'll be helpful, right? I think that'll be something that we can take advantage of to provide better positional accuracy going forward. I mean, there's a lot of discussions here about AR cloud, right? And really a pervasive AR cloud that's updated. Really, I think of it as like a global surface for being able to provide better positional accuracy using sensors that are available in devices to be able to edge match and provide a better location for devices that are out in the field. And so that's something that obviously is of interest to a variety of industries, whether they're affiliated with Esri or not. That's more of a general sort of industry interest at this point. What we might be looking at there, and this is just me thinking out loud, is that in situations where you want to be able to get better positional accuracy for an enterprise, but you don't want to share your data publicly, what we might be looking at there is maybe an AR cloud opportunity within the ArcGIS platform, right? So that we can better orient and locate devices that power an augmented reality experience going forward, but it's private in that context, right? So that's something that we can manage for an organization. That might be something we're thinking about. That's just me thinking out loud. There's no plan for that. It's just me thinking that that's probably where that's going to go, or there's probably going to be some opportunities there.
Actually, spatial anchor are really good to be able to share your position with other users. So it definitely works in an AR environment where you want to be able to have multiple users looking at the same thing. And that's basically going to be used if you want to build an AR application using the runtime. That will be used to figure out what your initial position is compared to that spatial anchor, how you're looking at which angle you are, and then you will have a good initial position on your device. And from now on, you use the ARKit so you can move around and the model will stay in place, which is good for AR, but also you can build applications that are not related to AR with the same kind of mechanism. But it's just spatial anchor is a really good way to get a good initial position and be able to share it with multiple users so they feel like they're looking at the same object that could be physically there, even if it's actually virtual.
Here, guys, I'm going to pop this up real quick, just in case, so that you guys can see this. Oh, that's nice. Hold on. It's a nice drag there. That's great. Good stuff there. Hold on. Delete. Thank you. Oh, that's good. Thank goodness. Hold on. I'm going to put that down. Actually, I can't do it with one hand. There we go. There we go. A little bit bigger. Let's our way through. There we go. Good stuff. Right. So here's the email address if you guys want to be able to join the beta program. I know there are a number of folks that aren't already in it. Feel free to take a picture, fire it off. It'll end up going to myself and Adrian behind the scenes. We'll be able to get you in the program, and then you guys can join in and start working with us, working with the community on this. One thing to keep in mind too is that if we deliver, obviously there's the research that I talked about in the game engine world. When we deliver a beta, we'd like to deliver a beta. When we deliver a beta, we'll probably use the same beta program, right? So even if you need something that's integrated with a game engine like Unity or Unreal, but runtime really doesn't fit your need at this stage because you need a premium AR VR experience or a VR experience in general. It would probably be good to get to this beta so that when we do have that initial offering, we'll be able to start working with you or communicating with folks that are part of the beta program already. I have to admit, we've got about 250 people in this beta program. About a quarter of those folks that have joined have specifically mentioned that they want to use a Unity API. So why not reuse the existing beta community to kind of drive the development feedback that we get from a game engine, a lightweight game engine integration API. All right, guys, any other questions? Good stuff. Well, thanks, guys, for Thursday afternoon attending. Listen.